Hello my dear students, welcome back to Learn Physics. In today's video, we are going to discuss about alternating current. In last video, we discussed about the alternating current when it is passing through a resistor. Today we are going to discuss about when an alternating current is passing through an inductor, what will happen? Okay, so in a circuit, this is an AC circuit. Through an inductor, if current is passing, what will happen? Okay, so inductor means a coil. Through a coil, when current is passing through the coil, we know an EMF will be inducing in it. All those things we know, right? So magnetic field linked with the circuit will be changing and induced EMF and back EMF will be producing, and that and all we know. Now we are going to discuss about what will happen. What will be the change which is happening for the voltage and current when AC voltage is passing through an inductor. AC voltage we know voltage V equals Vm sin omega t. Right? Here we are going to find out the current passing through the circuit. Now, if I am considering this whole circuit, whole closed loop, and I am applying Kirchhoff's voltage rule over here, how we can write down V? V is the potential of the AC circuit. Here it is L into di by dt as per Faraday's law, that is equal to 0. So here we can write it as V equals L into di by dt, or we can write it as di by dt equals V by L. Okay, this is the current which is flowing through the circuit. Now we need to find the rate of change of current. Now we are going to find out the what will be the current flowing through the circuit. Di by dt equals V by L, or we can write instead of V as Vm sin omega t divided by L. Okay, this is di by dt, multiplying with dt on both the sides, or I am taking this cross multiplying. Di equals Vm sin omega t divided by L into dt. dt also there. Now we are going to find out the current. What is the current? How we can find out? Integrating both the sides. I equals integral Vm by L sin omega t dt. Integral sin theta is minus cos theta. So we will get it as Vm by L minus cos omega t divided by omega, because again we should differentiate and divide. Right? So omega is the differential of omega t and we are dividing that. So minus V by omega L into cos omega t. This minus cos omega t I am representing in terms of sine. Sine of omega t minus pi by 2. Like this I can represent, right? Cos omega minus cos omega t, I can represent it as sine of omega t minus pi by 2. So this I value will be Vm by omega L into sine of omega t minus pi by 2. So in this equation, see, when we are applying when we are passing this through the inductor, if you are passing alternating current, the current which we got as Vm by omega L into sine omega t minus pi by 2. So this Vm by omega L, I am considering it as Im sine omega t minus pi by 2. So if we are comparing this voltage and current, what difference you are observing? Yes, both are not in phase with each other. That means they are out of phase. One is omega t and other is omega t minus pi by 2. Minus pi by 2 means current is behind the voltage by a factor pi by 2. Because I equals Im sin omega t minus pi by 2. V equals Vm sin omega t. That represents the current is behind omega t minus pi by 2. That means current will be behind the voltage by a factor of pi by 2. So they will be having a phase difference of pi by 2. Okay, so this one I am writing down both the equations over here. V equals Vm sin omega t, and we got I as Im sin omega t minus pi by 2. Okay, so both are having a phase difference of pi by 2. Next we are going to find out what will be the average power in the circuit. Power, how we found out in the previous case, power P equals V into I. Here V equals Vm sin omega t, I equals Im sin omega t minus pi by 2. So when we are calculating this one, we will get it as P equals average power equals Vm into Im sin omega t. This is cos omega t, right? Cos omega t minus. So sin theta cos theta, 2 sin theta cos theta, we know it is sin 2 theta. Right? So sin 2 theta divided by 2 minus Vm Im by 2 into sin 2 omega t. This is the average power. Average power we are getting it as this is the instantaneous power. P equals minus Vm Im sin 2 omega t. This is the instantaneous power. If we are calculating the average power, average of Vm Im by 2 into average of sin 2 omega t. What is the average of sin 2 omega t? That is equal to 0. Average of sin 2 omega t is 0. Therefore, average power in an inductive circuit will be equal to 0. Okay, average power in an inductive circuit is equal to 0, and here we are getting it as I equals Vm by omega L into sin omega t minus pi by 2. In that, Vm by omega L is equal to the current, maximum current which is flowing through the circuit, that is Vm by omega L. Right? So, if I am taking the value of Im, maximum value of current is equal to Vm divided by omega L. If we are comparing this equation with the Ohm's law equation, I is equal to V by R. So, while we are comparing with that, in place of R, here we are getting it as omega L. Okay, so omega L is called a inductive reactance. Omega L is called as inductive reactance, which is represented as XL. XL equals omega into L. Okay, so this omega L is called a inductive reactance. So if we are representing these voltage and current in a phasor diagram, how we can represent that? See here. First, I will draw the diagram for voltage. This is the diagram for voltage. 0, pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. Okay, so this is the voltage circuit, and current means it is lagging behind the factor pi by 2. That means when the pi by 2 is maximum, at that time this current will be reaching here only. Okay, at 0, pi by 2 behind, it will be reaching. So this is ahead and this is behind. So current, instead of 0, the same voltage value, the same current value will be starting from pi by 2. Okay, both are having a phase difference of pi by 2. So what is the value, whether it is a minimum value or maximum value at 0, that will happen at pi by 2 only in the case of current. So here for voltage at 0 degree it is 0, then at pi by 2 it will be 0 for the current value. Then we know it is less than, not maximum, the same way, Vm by omega L, it's less only. So voltage value also less. Then at 0 what is happening here, and then this is what happening in the case of, so here 0, you just see at 0 it is minimum, at pi by 2 it is minimum, at pi by 2 it is maximum, at pi it is maximum. So it is having a difference of pi. Okay, so here when you are taking these two, the same value is happening at pi by 2 behind. Okay, so current is having a value pi by 2 behind. Okay, so pi by 2 behind the voltage. Clear, children? So this is about the diagram. Now we are going to look at the phasor diagram for the same. Okay, this is voltage, right? So if I am considering another value over here, this is voltage value, and the same current value I can observe over here, that is current is pi by 2 behind. This is the current value. Pi by 2. This is Vm sin omega t. This is Im sin omega t minus pi by 2. Okay, children, clear? This is having a phase difference of 90 degree. This is a phasor diagram to represent the if an AC circuit is passing through an inductor. Okay, so voltage is moving ahead than current. Voltage is moving ahead than current, or current is moving current is behind the voltage. Okay, clear, children? Next we are going to look at the theory behind it. Okay, so here this is here a current coil is wound over it. Okay, a coil is wound over it like this, and okay, current is coming out, and this is the current which is flowing through it. Okay, this is how current is flowing through it. Now, when current I is passing through it, it is moving. When I am looking at that circular loop, the current is from here to here. It is moving in the anti-clockwise direction. When it is moving in the anti-clockwise direction, magnetic field will be developing, and this side will be north pole and this side will be south pole. As the current is moving more and more, see, current is increasing. When I am considering the AC circuit, current will be increasing from 0 to pi by 2. Okay, till 0 to pi by 2 current will be increasing. That increase we will be representing from 0 to pi by 2. This is the value of pi by 2. Till pi by 2 it is increasing. So when current is increasing, this magnetic field also will be increasing in such a manner. So voltage and V and I are positive. So product also will be, P also will be positive. Energy will be absorbing over there. So energy is absorbing here. Then after reaching to maximum value, what will happen? Till pi it will be reducing. So there, how the current will be flowing here? The current is flowing in the same direction only. This side is north pole, this side is south pole. Current is flowing in the same direction only, but the number of magnetic field lines produced will be less. Okay, number of magnetic field produced will be less, means V will be positive itself, I will be negative. The current is decreasing with respect to time, so I will be negative. Okay, when I is negative, here current is returned, the energy is returned to the source itself. Next, in the next half, what will happen? It will be moving in the negative direction. When it is moving in the negative direction, when current is moving in the negative direction, what will happen? This side will become south and this side will become north pole, and here V and I will be negative. Then P will be positive only. Here also absorbed from the source. Total energy will be absorbed from the source. But when we are considering, this is from pi by 2 to 180. This is what happening. Then next is from pi to 3 pi by 2. It is increasing in the negative direction. Then from 3 pi by 2 pi, what will happen? This V is positive and I will be negative again. So here it is returned to the source itself. Okay, this is the energy will be returning to the source itself. This is what happening in the case of, this is the theory portion behind that inductive circuit. Okay. Next we will do one numerical based on that. An alternating EMF E equals 220 sine 100 pi T is applied to a circuit containing an inductance L equals 1 by pi Henry. Write the equation for instantaneous current through the circuit. What will be the reading of AC ammeter in the circuit? So we need to find out the what will be the reading in the ammeter. Ammeter reading means we should find out the current. RMS value of current we need to find out. So E is given. E equals E0 sin omega t. Okay, so maximum value of voltage is given as 220 volt and omega is given as 100 pi. So I equals I0 sin omega t. How we can find out I0? I0 will be equal to V0 divided by omega L. V0 is 220 divided by omega is given as 100 pi into 1 by pi. So here we will get the answer as 2.2 ampere. Therefore, I will be equal to I0. What is I0 value? 2.2. So 2.2 into sin 100 pi t. Omega t, sin omega t minus pi by 2. Sorry, minus pi by 2 also there. Okay, because it is inductive, inductive circuit, omega t minus pi by 2. This is the value of current. Now we need to find out what will be the ammeter reading. Ammeter reading means IRMS. RMS value of current we should find out I0 by root 2. Therefore, 2.2 divided by root 2. This will be the RMS value of current. Okay, clear? So this is the same kind of questions only will be asking. So here you should remember that inductive reactance, how we can find out. It is using the formula omega into L. Okay, clear? So the next question, a pure inductor of 50 millihenry is connected to an AC supply of 220 volt 50 hertz. So a pure inductor of 50 millihenry. L is given as 50 into 10 to the power minus 3 Henry. Millihenry means 10 to the power minus 3. It is connected to an AC supply of 220 volt. So voltage is given as 220 volt. Frequency is given as 50 hertz. Find the inductive reactance. Inductive reactance means XL, that is equal to omega L. Omega L is the inductive reactance. Omega, how we can find out? 2 pi nu into L. Nu value is given, L value is given. 2 pi into nu into L you can find out. And impedance. Impedance means you should find out the resistance. What will be the total resistance? Then you should find out the RMS value of current and peak current. IRMS equals I0 by root 2. And you can find out I0 will be equal to V0 by omega L. All the values are given, so you can easily find out. I will give the I0 value as 19.8 ampere. Okay, I0 value will be 19.8 ampere and IRMS will be equal to 14 ampere. Okay. So I think this one you can easily find out. This numericals and all won't be difficult for you. Here you should remember that your I is lagging behind the voltage by a factor pi by 2 and inductive reactance is equal to omega into L. Omega L is the inductive reactance. Okay, it's equivalent to the resistance in the resistive circuit. Okay children, it's clear for you? Okay, then in next video we will be continuing with our capacitor. If AC circuit is connected to a capacitor, how the changes will be happening. Okay, so I think this is clear for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.